So I'm sending the slides as well. Okay, so as we were discussing that if we are generating the message digest from a message function or message, if it is generating a message code and we cannot regenerate the original message from that message code or digest, so that means it's a one-way property. So if we are, for example, we can generate the same message code from different messages, or same message digest from different messages. That means it's a weak collision resistance. So if we cannot regenerate the same messages from to different message, so that it is called a strong collision resistance. So in order to have the property of the data, uh, proper security of the data, proper integrity of the data, it is required that every message should regenerate the message authentication code, which should be different from some other message. So that is why we say that it's a strong collision resistance. And then we have uh, hash function. uh, that could be possible that some hash function maybe depends on like functions like exclusive OR functions, or some hash functions may depend on some other functions. So it depends on the types of the function that is used to send the data. So it is actually used to send the data using different functions. So these different functions are actually applied on the message. So it could be exclusive OR function or some other type of function which can be used by the attacker. So there are different attacks can be applied on such type of functions or message authentication codes. Like for example, there's a function that is called as a there's a take that is called birthday take, which is applied on a function, message authentication function. When it is applied on message authentication function, so it can produce uh, some data which has been maybe modified by an attacker using an attack which is actually called as a birthday attack. So how that attack is applied on a function, for example, it uses a formula like it creates a code from a message like 2 power n divided by 2, and it will generate that much variations of different messages. And after creating these much variations of different messages, then it will calculate that uh, that how that particular message, at what probability of that particular message is would be having the same code which is actually generated from the message. So if it is actually having a you can say more probability of creating the same message uh, from different same code from different messages, that means uh, it is it is actually the method that is actually uh, is more vulnerable by the attacker. So he can modify that message as well. So he can use maybe another message, and that is generating same code. And when it is generating the same code, that means it is actually when it is received by the receiver, it is a possibility that the attacker can send its own code. And when it is using its own code to uh, when it is using its own code of the data. So that means he can be able to generate a message from that. So such type of attacks is called as a birthday attack. So that can be launched on the hash function. So in the same way, we further discuss that how different other methods are used for the hash function. For example, if we can apply a hash function on a block of data. For example, when we apply a hash function on that, so then it will generate a hash code for that particular block. So when it is for example that particular, when we want to authenticate that particular block of message has not been modified, so we will regenerate the hash code from that block of code, and verify that the code or message digest which is generated from that block to the block which is actually the original block. When it is actually same, that means the message or the block of code has not been modified. So in this way we can there's a possibility of different attacks, like as we discussed, a birthday attack or maiden middle attack. For example, where an attacker can receives the message, and there's a possibility that he can modify the message. So if because there's a chance of generating the same message code from the message, so that's why he can regenerate the same message digest for the same message. So that means in this way he can be able to send another message to the receiver, and then receiver will get the same message code with the as it with same message code as the message which has received by them that receiver. So it can compare that it will have the same message code would be received by the receiver. So in this way he can also have the same message code. There's a possibility of the same message code which would be generated from the message from another message which is actually used by the attacker to send to the receiver. So in this way we have a main and middle attacks. So it can modify the message, or he can send another message to the receiver. So we can have different other functions can be applied. For example, brute force attack can also be applied on uh, on on the functions like hash functions. For example, here different messages are used. So it can use different messages and apply the hash function on that. And if it check if it creating the same message code. So if it creating the same message code, then that particular message would be used to send to the receiver. Now, if it is creating the same message code, then the receiver will think that it is actually the legend, it is actually the actual message which has been received by the receiver, because it is generating the same message code. So that is why the attacker will be will the receiver will think that it is a legend, it is an authenticated message, or it is a message, or it is an original message which is received by the receiver to the receiver. So in this way, uh, there's a there's a, we can say, brute force attack can be applied. There's a birthday attack can be applied. There's a man in middle attack can be applied on codes like hash function and message authentication. So uh, we uh, we, in order to protect such type of from such type of attacks, we will apply different uh, cryptographic algorithms, and we will apply different methods to protect the message from such type of attacks. Like for example, here there's a formula is given here. For example, where generates a, you can say, hash code from that particular code. So actually, we need to ensure that the same message code will not be generated by different messages. So we need to ensure that the only every message should generate a different code for that. So we will have to select, or we will have to uh, uh, we will have to give the formula of the hash function, that particular formula or that particular function, that will not regenerate the same message code from different messages. So in order to protect the message from such type of attacks, this we ensurety, we have to give the ensurety to the message. We have to give the ensurety